My name is Chris Bauman. I'm with Mizar Imaging, and I'm here with Dr. Paul Maddox, president and founder of Mizar Imaging, also associate professor at the University of North Carolina, Chapel Hill. Paul's lab is the one who developed the technology surrounding the tilt, and he's going to tell us sort of the origin story of that today. Hi, Paul.
Hi, Chris. Thanks for having me on. And as you can see, I'm in my basement, and this is where I operate from now. And so the story begins around 2015, I guess, when my wife Amy was doing some imaging on a dice BIM with Hari Shroff in Woods Hole, and getting some really great movies and of my wife studied cytokinesis in C. elegans mainly, and so I thought, well, I'll build a light sheet at home, and got back home, and I had a technician at the time named Tanner Federo, and he was very eager to build, and so we had all the parts to build the OpenSPIM, and I said, well, okay, let's just sort of get started, and then the goal was to build a Bessel beam based system following the Betzig Lab blueprint, and you know, I spoke with those guys about using their software and all that kind of stuff, and it was all gonna work out fine, I think. And so we got going, and I realized at some point that you know, I wasn't really probably going to use this much in my own lab because we use sort of minimally, you know, 1.3 NA detection objectives, and so at some point I went to Tanner and I said, let's just stop, and then let's step back and design something that from the ground up that we would want, that would have more sort of utility for the kinds of things that we were doing, and so that meant using oil immersion objectives, and which then comes with a whole level of issues. So we designed it from the detection objective backwards, and so we had several ideas and plans, and in the end we finished on what became the tilt, what we called light for lateral interference tilted excitation, and so that's the sort of true origin of it. In the development of this, we were sort of we did it all empirically. So I'm a biologist. I'm not an engineer. I have taken a lot of training in sort of physics and things like that, but I'm not I'm not really a physicist or an engineer, and so we designed it around the specimen and the objective, and in doing so we built it on a stand that we already had, which ended up being a Nikon inverted TE2000, and it had a prior stage on it, and XY stage, and we ended up 3D printing a bunch of parts and doing a bunch of things, and then we even used, you know, styrofoam coolers and cardboard at different points, and so we ended up with what we called our prototype. And then once we got to that, which was sort of a breadboard, optical board with the optical parts mounted on there, including with a fiber optic coupler, and then so then that was mounted beside the microscope. So I happen to have an objective here, teaching, but so here's a 60x oil objective, and so the objective is pointing up like this, and we had the breadboard on the side, and right up next to where the objective would be, and so we delivered the light right there. And so that was totally independent of the microscope. It was on a XY translator that was made from old manipulators that we had, and then it was a little quirky, and actually to move the sample relative to the light sheet, and to move the microscope and everything, you had to actually physically move the microscope. And Tanner got really good at that. He could just sort of bump it, and it would move a little bit, and it was kind of it was definitely an art form at that point. And the problem with that is that, you know, that's not a very user friendly arrangement, and it's certainly not laser safe for a normal operation. So Tanner and I and a couple others were really the only people who could actually use it. And so that's how we got to our sort of, you know, got to make a company and to make something that other people could actually use, and in a more safe and practical way.
At what point did you realize you had something really cool there? Was there that one moment?
Yeah. So that was 2016, and I remember going to the AQLM course, Analytical Quantitative Light Microscopy course in Woods Hole, and we had just taken our first movie, and this was with the breadboard stacked up on styrofoam coolers next to the microscope. And, you know, we had no shutter on the laser. It was just full illumination, and we took this time lapse of centromeres in a C. elegans embryo, and the centromeres are about 800 nanometers separated, and you could see them oscillating back and forth and dividing, and one cell divides up out of the out of the light sheet, and it disappears, and it was just super cool, and it didn't really bleach, and I was like, holy moly, this is actually, you know, we've done something good here. And that was really the sort of aha moment, as it were, that we had really sort of maybe sort of naively made a really powerful imaging device, I think.
Cool. And then from there, how long did it take? Sort of, what was the process to get it sort of a production? And
Right. So the next step was to file a patent, and so that's something else I'd never done, and that's something I'd never done, and so we talked to the patent office here on campus, and so we also had to, you know, we designed it empirically, so we hadn't done any simulations or math or anything ahead of time, and so we had to actually do that after the fact. And so we spent the summer, that summer of 2016, working out the details of how it works, and as best we could explain why it works. And there's still, you know, there's still debates about that. We can still debate about some of that. And the patent was awarded in September, and then I ended up talking to various people about how to make it, how to make a production, manufacture something, and something I've never done, and we ended up working with Cairn Research in the UK in Faversham, and we came up with the original sort of you know, tilt Mark 1 sort of design, and we made 5 of those in partnership with Cairn, and started a company and started Mizar in February of 2017. And so the whole sort of, from idea, which was in sort of November 2015, to company, which was February 2017, was, you know, a little under 2 years. So or a little over, yeah, a little under.
cool. Well, very interesting how that sort of, from just starting with a basic problem and just not, without even trying, you got to where you are now.
Yeah, I mean, people who know me may know that I'm kind of a stubborn person, and so I sort of decided, okay, this is we're gonna use a 60x oil lens or a 100x oil lens with a light sheet, and I wasn't really prepared to take no for an answer to that, and so that's how we got to where we are.
Were there any kind of significant wrong turns in the process where you started going down the path, you said, oh crap, that's not going to work?
Oh yeah, we had sort of three. Well, we started off with kind of like 10 thoughts about how to do it, and then one of them was I thought was a particularly promising one, and then it turned out it was just totally fatally flawed, for a lack of understanding on my part about how microfabrication and other things work, and so that went right out the window, and Tanner still teases me about that. But the end result, the light technology is sort of an amalgam of several ideas, and it was almost the path of least resistance to get to our goal, in the end.
All right, cool. Well,
Yeah.
Thank you very much for your time.
Yeah, thank you, and I hope everybody's out there enjoying some time at home and staying safe and staying busy. There's lots of good stuff to watch and to do.
It's time to binge.
All right.
All right. Thanks.
Yep. Take care.